I'm Professor Rad, this is Lenny, and this is Precalc video 3.2, Basic Trig Identities. So in our last video, we talked about some trigonometric definitions for our trig functions on the Cartesian plane. In this video, we're going to be talking about 4 types of identities, bless you, goodness, and how to apply them. So if you're using our trig reference sheet, this is going to be filling out the rest of the first page. So we're going to be filling out those 4 different properties at the bottom. So we're going to start out with the reciprocal identities. So here's where those come from. So notice that when we have our sine, cosine, and tangent, I kind of wrote out cosecant, secant, and cotangent to go along in the same order. Because if I take the reciprocal of sine, I end up with cosecant. If I take the reciprocal of cosine, I end up with secant. And if I take the reciprocal of tangent, I end up with cotangent. So because these relationships are reciprocals of each other, we're going to call those the reciprocal identities. So let's summarize that on the board. So these are the reciprocal identities. And when we're writing reciprocal, oh my goodness, this cat today. When we're writing reciprocal, we usually write it as 1 over the thing. So that's how I'm going to write these. So I can say that cosecant of theta is 1 over sine theta. Secant of theta is 1 over cosine of theta. And cotangent of theta is 1 over tan theta. Now, it's important that you remember that these are reciprocal identities, because if you think of it as a formula of like 1 over, then you're just giving yourself complex fractions to simplify, which is going to be a pain to do. So we're going to write this notationally, but it's better to remember it in terms of reciprocals. Also, you can remember that since cosecant and sine are reciprocals, then sine is the same as 1 over cosecant. Right, so I could have written sine theta equals 1 over cosecant. That relationship would hold as well. So it kind of flips either way. We also have what are called the quotient identities. So let's develop those a little bit. So I'm going to develop them and then we're going to summarize them. So I'll develop them over here. So what I'm going to do is I'm going to take the ratio of sine theta over cosine theta, because it's a quotient of 2 trig functions. So for developing quotient identities, we should probably start with a quotient. So over here, sine of theta is y over r, and cosine theta is x over r. So over here, I'm going to write y over r over x over r. Now I can multiply the top and bottom by r, and that will give me y over x. So sine theta over cosine theta is the same as y over x. But y over x was the same as tangent. So that's our first quotient identity, that tangent is going to equal sine over cosine. So for our quotient identities, we have that tangent of theta is sine of theta over cosine theta. Now, because tangent and cotangent are reciprocals, we can take the reciprocal of both sides and get that cotan theta is equal to cosine theta over sine theta. Now, what's really nice about the reciprocal identities and the quotient identities together is that we see that in order to understand all of our trig functions, you really need to just know sine and cosine. Because if I know the sine and the cosine of an angle, I can figure out cosecant and secant using the reciprocal identities. And I can figure out tangent and cotangent using the quotient identities. So the key to trig is sine and cosine. If we understand things with sine and cosine, we will be good to go. All right, so I'm going to erase the board to make room for a couple of other trig identities. All right, for our next identities, we do have to do a little bit of math to build them up. So I'm going to start out with this relationship here, that x squared plus y squared is r squared, right? Because these originated from a right triangle, so we have this Pythagorean theorem. Now, if I look at, for example, sine or cosine, I notice that I have a y value over r and an x value over r. So in this equation, because I have an x and a y, if I wanted to get an r into the situation, I could divide by r, and that would give me x over r and y over r. So now I can write things in terms of sine and cosine. Okay, so because these are being squared, however, I'm going to divide both sides of this equation, not just by r, but by r squared. So then I can summarize this piece here as x over r squared. And then this one, I can write this as y over r squared. And then over here, r squared over r squared is just going to give me 1. All right, nice. So now we get this relationship here. We know that x over r is cosine and y over r is sine. So we can write that cosine of theta squared plus sine of theta squared will equal 1. So this is called a Pythagorean identity. It's called that because it comes from the Pythagorean theorem, from that Pythagorean statement. Now, also just to comment about notation. All right, Lenny doesn't like notation apparently. So for a comment about notation, having to write these parentheses all the time is kind of a pain, and mathematicians don't like to waste pencil lead or marker ink or things like that. However, if I didn't write these parentheses here, it might become confusing whether I'm squaring the angle or whether I'm squaring sine or cosine of the angle. So the notation that we've adopted is to write cosine squared theta plus sine squared theta is equal to 1. But just a reminder, this notation means find cosine of the angle and then square it. Find sine of the angle and then square it. Now, in this particular instance, I chose to divide by r squared, but I really could have divided by either x squared or y squared as well. So for instance, if we had divided by x squared, say, we would get our x squared over x squared plus y squared over x squared is r squared over x squared. So x squared over x squared would be 1. Y squared over x squared, I could think of that as y over x squared. And r squared over x squared, I could think of that as r over x squared. Now, y over x is the same as tangent, and r over x is the same as secant. So we could rewrite this as 1 plus tan squared theta, I'm going to adopt that notation here, is equal to secant squared theta. So by dividing by x, we now get this identity. And if we had divided by y instead, or y squared instead, we would have gotten an identity that's got cosecant and cotangent. So let's find my eraser, erase these, and summarize the Pythagorean identities. So Pythagorean identities. We've got cosine squared theta plus sine squared theta equals 1. 1 plus tan squared theta equals secant squared theta. And cotangent squared theta plus 1 is equal to cosecant squared theta. So those are our three Pythagorean identities. And if we're working on our trig fact sheet, we have one more left to do, and that's going to be the sign, S-I-G-N, not S-I-N-E, of each of our trig functions. So the signs of the trig functions. To start out with, I'm going to draw my coordinate plane, and remember that we label the quadrants starting from the top right and going counterclockwise. So this is quadrant 1, this is quadrant 2, 3, and 4. Now there are a few different ways that you can remember whether a trig function is going to be positive or negative. The one that I learned is that all students take calculus. So what you want to take away from this is A, S, T, C. So all students take calculus. What these letters are telling you is which trig functions are going to have a positive value in that quadrant. All of the other trig functions are going to have a negative value. So here, A stands for all trig functions. All trig functions will be positive in the first quadrant because the x value and y value here, the x and the y, are positive numbers, and r is always positive, so you just get positive values. In quadrant 2, S is standing for the sign function. Now, you want to use your reciprocal and quotient identities as well to kind of help you with these. If sine is positive, cosecant is positive as well, since sine and cosecant are reciprocals. So that means that cosine and tangent and their reciprocals of secant and cotangent are going to be negative. So if I think about y, if I'm living in quadrant 2, the x value is negative, but the y value is still positive. So the y value is going to be positive, the x value is negative, and then positive over negative will give us a negative. And then for quadrant 3, T stands for tangent. That's because x is negative and y is negative. So you get a negative over a negative, which will give you a positive. And C is for cosine. So in quadrant 4, the x value is positive, so cosine will be positive. Sine and tangent will be negative in the 4th quadrant. All right, so what I'm going to do is I'm going to pause and I'm going to summarize all 4 groups of these properties on the board just in one nice picture. Alrighty, so here are all 4 of the properties that we were talking about, summarized kind of nice and concisely in one spot on the board. So now I'm going to talk about how I remember these. So one of the things that really resonated with me as a mathematician when I was reading a Precalc book, this was by Sullivan Precalc, and when he talked about these trig identities, he said you should really know these identities, not just memorize them, right? You can memorize information. You want to know these identities in the same way that you know your name. So if someone asks you your name, you don't need to pause to like recollect it usually. It just like comes to you like that. That's where you want to be at with these, with this group of identities, as well as with these definitions. Now, it's okay when we're first learning to kind of, have to think about them, but I would recommend to really get to know these and make sure, practice them every night, put them on flashcards, or try to write them all down before you go to bed. And then when you wake up in the morning, try to write them all down again to try and help yourself start to get to remember these and to know these in the same way that you know your name. So when I was first learning these, here's how I remembered them to help me to learn them. So what I did to remember the reciprocals is that everybody's partner is a co. So sine's partner is cosecant, secant's partner is cosine, and tangent's reciprocal is cotangent. This is because in my world, in my head, it would make sense for cosine and cosecant to be the same and secant and sine to be reciprocals because they start with the same letter and it would make sense. So I had to train my mind that no, it's not like that. It doesn't make sense with the words. Remember it instead, everybody's partner is a co. Okay, so there's always one co and one non-co when you look at the reciprocals. For the quotient, the way that I remembered it was using the cotangent one because I have CC. So cotangent, I'm going to start out as cosine over sine. So I have CC here for quotient, cotangent, cosine. Then I would know that tangent is the other way around. So tangent is going to be sine over cosine. There we go. For the trig signs, I already told you all students take calculus. So that's how I would remember this one going around. You start in quadrant 1, all students take calculus. So that's how we remember those. And for the Pythagorean, I'll be honest, this is one I just had to memorize until I knew. And this was too much for my brain. My brain is not very good at memorizing things. So I forgot about tangent and cotangent because I said, you know what? If I know these two, then I can derive these if I need them. So what I really focused on remembering is that cos squared plus sine squared is 1. And of all of our trig identities, when you get to calculus, this is the shining star. So this is the trig identity that when you get stuck on something in calculus, that's the one you want to go to. You're like, I don't know what to do. Cos squared plus sine squared is 1. Let's try that out. At least that was my experience in calculus. That's what saved me time and time and time again. So this one you want to know. These others, if you can memorize stuff well, great, go for it. If not, you can get by just knowing cos squared plus sine squared is 1. And then you can use the reciprocal and the quotient identities to help you out. So while these are all on the board, let's do a few examples of applying them to find some values. So where are my examples? Here we go. So we'll just do 2, just to see them in action. So for part A, I've got tangent of pi fifths radians, and we're going to multiply that by cotangent of pi fifths. And then for part B, I've got secant squared of 12 degrees minus tan squared of 12 degrees. Yeah, that seems good for now. All right, so when you are trying to simplify trigonometric expressions, you can always go back to sine and cosine, or you can use any one of these relationships that we have here. So I know that tangent and cotangent are reciprocals of each other. So that's what I'm going to do here. Now be careful when you find the reciprocal. We're not finding the reciprocal of the angle. We're finding the reciprocal of the whole function. So I'm going to keep tangent the same. And for cotangent, cotangent of pi fifths is the same as 1 over tangent of pi fifths. So again, the angle stays the same. I'm not taking the reciprocal of the angle. I'm taking the reciprocal of the trig expression. Now I have a thing times 1 over the thing. So the things cancel. And we're just left with 1. So tangent of pi fifths times cotangent of pi fifths is going to give us 1. Yay. For the second one, we have secant squared and tan squared. So when you see a trig function being squared, you want to think Pythagorean. Since I have these listed right here, I'm just going to go ahead and use the Pythagorean identity here that's got secant and tangent together, because that's the second one, has secant and tangent together. And then I'm going to go through this one and I'm going to show you how you can revert back to in terms of sine and cosine to figure this one out. So you can see if you forget the identity that involves tangent here, an alternate way to kind of figure it out. So in this case, we have the statement that secant squared is 1 plus tan squared. So I'm going to replace secant squared, or secant 12 degrees squared, with 1 plus tan squared 12 degrees. And then I bring down my minus tan squared 12 degrees. Now I have tangent squared of 12 degrees minus tangent squared of 12 degrees. They're the same, they become 0. And we're just left again with 1. So there you go. So that's how we can figure that one out, like the easy way, if you know this identity. But if you, like me, don't have a lot of memorization space and you forget that identity, but you remember your reciprocal and your quotient identities, and this big one here, here's how you can get through it. So I'm going to start out with my secant squared, 12 degrees, minus tangent squared, 12 degrees. So the first thing I'm going to do is rewrite this in terms of sine and cosine. So secant is the reciprocal. Since this is not a co, it's the reciprocal of a co. So it's the reciprocal of cosine. So secant squared 12 degrees is going to be 1 over cosine squared of 12 degrees. Minus. For tangent, I'm going to need my quotient identity. So tangent, well, I know that cotangent, I have CC. So cotangent is cosine over. So tangent's going to be sine over. So tangent squared is going to be sine squared 12 degrees over cosine squared of 12 degrees. So that's my first step. Get it in terms of sine and cosine, because that's my key. Now, fortunately, we have the same denominator, so we can subtract, and we'll get 1 minus sine squared 12 degrees over cosine squared 12 degrees. Okay. Now I see squareds happening here. So with squareds, you always want to think of the Pythagorean identities, that sine squared plus cos squared is 1. So here I have 1. So I can rewrite 1 as cos squared plus sine squared. So 1 is cos squared 12 degrees plus sine squared 12 degrees. Then I have my minus sine squared 12 degrees over cosine squared 12 degrees. Now sine minus sine is going to cancel out, and I get cos squared of 12 degrees over cosine squared of 12 degrees, and cosine over cosine is 1. Ta-da! So if we know this trig identity about secant squared, it's like, boom, we're done. If you don't, but you know your other things, you can figure it out. It just takes a little bit more time. Now, I happen to really like algebra, so this sort of thing is like calming to me. If it is not calming to you, that's fine. So in that case, you want to focus on memorizing your secant and your tangent Pythagorean identity. But if you don't mind doing a bit of algebra and you're short on memory space, then you can always go back to sine and cosine as your key to the problem. All right, so that's going to conclude this video on our trig properties. In our next 2 videos, we're basically going to be doing the same examples, just in different ways. So in the next video, we're going to be finding some trig values using the definitions for our trig functions. And then in the following video, we'll be doing exactly the same examples, but instead of using trig definitions to evaluate them, we're going to use the properties to evaluate them. So you can kind of get an idea about which method you prefer, what's going to work easier for you. So I hope this video helped you out with those basic trig identities. I look forward to working with you in the next video, but in the meantime, I hope you have a magnificent day. Bye for now.